Okay? Sounds like stuff that you can probably verbalize. Go ahead. That is the inverse cosine, or arc cosine. In other words, inverse and arc mean the same thing. So arctangent means inverse tangent. Arc sine means inverse sine. Arc cosine means inverse cosine. Okay. Let's talk about something here. If we take the trig function of an angle, we always get a ratio. Over on the right, can you see all of that? Okay. What that means by definition is if we take the inverse sine of the ratio, we get the angle. So if you're trying to solve for angles, you take inverse trig function. If you're trying to solve for ratios, you take trig functions. You with me? So when I talk about the inverse cosine of 1/2, I'm looking for what angle would the cosine of that angle be equal to 1/2? Well, which angle is that? In other words, this goes together by definition. And what they're asking for is theta. So if you review your triangles, which angle is the cosine of that angle equal to 1/2? Looking at this picture over here, which one has the cosine of the angle equal to 1/2? In other words, we're trying to solve for theta. What's the cosine of 30? Always got to start with SOHCAHTOA. Always. Got to know it by heart, backwards, forwards, and like the back and front of your hand. Okay, so what is theta here? Okay, and do you understand why? Because the cosine of theta is 1/2. So when we have this problem right here, we're trying to solve for the angle, not the ratio. Very important that you understand which one you're trying to solve for. When you have a trig function, you're trying to solve for the ratio. When you have an inverse trig function, you are trying to solve for the angle. Okay, let me give you a couple of others. I'm going to draw the two most common triangles that come up all the time that they want you to know. You just have to memorize these. One is the 30-60 triangle, the other is the 45-45. Both right triangles. These are the dimensions. Okay? So, if I said to you, the sine of 30 degrees is what? What's the cosine of 30 degrees? No, cosine of 30 degrees. Okay. So now if I said to you, what is the inverse sine of 1/2? What is it? Okay. And if I said, what's the inverse cosine of root 3 over 2? What is the inverse cosine of 1/2? You got it. So you understand trig functions and inverse trig functions? Okay, what's the inverse tangent of minus 1? We're looking for an angle. That's the first thing to know. That when you take inverse trig functions, you are looking for an angle, not a number. Yeah, because the tangent of 45 is 1. So the inverse tangent of 1 has to be 45. Got it? Okay. What else you got? Hold on. Hold on 1 second here. I may have to. I can try it like this. Go ahead. Okay. So what are they saying? That's equal to what? An angle or a ratio? Okay. So if I draw my sine curve, and if you're going to memorize any curve, that's the one you want to memorize. That's y equals sine x. That is 360. That is 180. That is 90. And that is 270. So what's the answer here? What value of theta would the sine of that be equal to minus 1? You got it. I think you get it. Just remember, you take trig functions of angles, you take inverse trig functions of ratios. Okay, what else you got? Okay. There are a couple of ways to do this. You can start from the inside and go out. Let's do it both ways. However, the second way is going to be the best way. But let's try starting from all of these problems that look like algebra kind of. You always start from the inside and work out, right? So what is the arc cosine of 1/2? Let's start there. We're starting on the inside. Is that an angle or is it a ratio? Okay, what angle is it? Okay. Now, what's the sine of 60 degrees? It's root 3 over 2. Remember that. That is a very common answer. When you're talking about sine or cosine, it's either 1/2 root 3 over 2 or root 2 over 2. One of those three answers. So it's not like this is an unusual ratio. That's an extremely common ratio. Okay? Now, that's one way to do it. That's not my best favorite way to do it. My best favorite way to do it is the following. I know that that's an angle, right? What's inside the parentheses is an angle. So I'm going to call it theta instead of arc cosine of 1/2. And now I'm going to solve the problem by drawing a triangle, which very frequently is the best thing you can do in trig, is draw a triangle and label theta. Okay, you with me? Dimension 2 of the sides of theta. And tell me which 2. Okay, where's the 1 go? On the base or the height? Where's the 2 go? No. What is cosine? Cosine, yeah. Cosine is adjacent over hypotenuse. So that has to be where the 1 and the 2 both go. And now, using the Pythagorean Theorem, you can figure out what the other side is. What's the other side? Yeah. So now tell me the sine of theta. No, the sine of theta is a ratio. Always remember that. Never forget that when you take trig functions of an angle, you get a ratio. When you take inverse trig functions of a ratio, you get an angle. So here we're taking the sine of an angle. We're looking for a ratio. Read that triangle. Tell me what the sine of theta is. Look at that triangle. Tell me what the sine of theta is. SOHCAHTOA. Sine. Okay. You got to know these. I'm not kidding you. The most important thing about trig is not memorizing these, but knowing them like you know your name. When somebody says, "What is your name?" you don't have to search your database of memories to figure it out. You know automatically what your name is. I want you to know these trig things like that. I want you to know SOHCAHTOA without thinking about it. In other words, get so good at it that you instantly know it. Now, notice that I did this 2 different ways and they both produce the same answer. The second way is the best way to do it. Drawing the triangle. Because sometimes you'll get one that's a little harder than this one was. And the best thing to realize is that everything inside the parentheses is an angle. As long as it's an angle, I can draw it and dimension all 3 sides of the triangle. Let's have another one. Similar to that. We need to do a few of these before you can really get it down. Okay? Okay, now the first thing to do here is to look at what's inside the parentheses and to understand, is that an angle or is it a ratio? What's our cosine? Okay, so let's label it theta. And that's an important part of this process, because then you can draw a triangle. And not just draw a triangle, but label a right triangle and label theta. Now start dimensioning that triangle for me. What's the base? What's the hypotenuse? What is the unknown third side? Use the Pythagorean Theorem to solve for y. It's always the case. All of these trig problems where you can put two dimensions on a right triangle, always have to use the Pythagorean Theorem to solve for the third side. Always. Does that fit any of your triangles that you're taught about? Is it a 5, 12, 13? Is it a 3, 4, 5? What is it? Okay, that makes that side 3. Or that side is the square root of 5 squared plus 4 squared. Excuse me, it's the square root of 5 squared minus 4 squared, which gives you 3 also. Now that you have this whole triangle fully dimensioned, you can look at it and tell me what the sine of theta is. That's the way we do it. Every single time that you're taking the trig function of an inverse trig function. Always do it this way. Now, give me another one, because you're going to have some that are a little opposite this. But we'll keep thinking these if it reinforces it for you. How are we going to do this? Well, hold on. What's inside the parentheses? Is that an angle or a ratio? Let's label it such. That's an important step in this process. Very important. To know whether that is an angle or a ratio. Because sometimes it's going to be a ratio. Okay? Now what's the next step that I know that that's an angle? Yeah, draw a right triangle and label that angle. Now dimension 2 of those 3 sides for me. Nope. Nope. Now what's the other side? Because that's always the next step. No, you got to use the Pythagorean Theorem. X is equal to the square root of the hypotenuse squared minus the other short side squared. Square root of that. No, it's the square root. Here, let me write it out. That's equal to the square root. It's always square root when you're solving right triangles. Always begins with square root of the hypotenuse squared minus the other short side squared. So what is that? Square root of 5. Square root of 5. It's the square root of 9 minus 4, which is the square root of 5. Okay? With me? Now, what's the tangent of theta? In other words, once I have the triangle fully dimensioned, not just two parts of it, but fully, all three sides, now I can tell you that any trig function of theta, what is the tangent of theta? Yeah, over 2. It's opposite over adjacent. There's the opposite, there's the adjacent. That's why you have to know these, like the back of your hand, is because you just have to apply it 100 times a day when you're taking trig. So learn it. What else? Okay, tell me what to do. Okay, what is it? Okay, so let's label it that, just so we don't forget. Now what? And not just draw a right triangle, but label what? Okay, I can choose either angle for theta. I'm going to choose this one right here. Now, begin to dimension that triangle. What are two sides of that triangle? Forget the sine for a moment. By that, I don't mean the SIN, I mean the negative 4. Just pretend it's 4. Just pretend it's 4 for a second. Tell me what is 1 and what is 4. The base or the height? Nope. Tangent is what? Okay. So opposite over adjacent has to be 4 over 1. Right? So that's 4. That's 1. And let's just forget that negative sign for another moment. I can still dimension this triangle. What is the hypotenuse? I've got to do that. In other words, I have to repeatedly apply the Pythagorean theorem. That's why I've tried to teach you how to do the Pythagorean theorem quickly, so you don't always have to go back to a squared plus b squared equals c squared. Nope, square root of 17. The hypotenuse is always the square root of the sum of the sides squared. When you are solving for the hypotenuse, it is different than solving for one of the sides. If you're solving for one of the sides, it's the square root of the hypotenuse squared minus the other side squared. But when you're solving for the hypotenuse, it's the square root of the sum of the sides. That is the Pythagorean theorem in a nutshell. Okay? Okay, so if that is our base triangle, what is the sine of theta? Okay, however, let's leave it like that for a moment and not worry about rationalizing that. First of all, let me ask you, has your teacher mentioned this rationalizing or not? Does he care, or does he tell you not to rationalize stuff? Okay. In Trig, most of the time, you can get away without rationalizing the denominator. And the reason is that sine of theta might be the first question, but the next question might be, what is the cosecant of theta? And the cosecant is just the reciprocal. So the cosecant of theta would be root 17 over 4. And you are very, very frequently looking at the reciprocals. So most trig teachers have gotten it by now that you don't have students rationalize everything. Doesn't make sense. It just increases your workload. Okay? So it's acceptable to leave it like that. Now, we're not done. First of all, I'm looking for the tangent of an angle that's equal to -4, right? What quadrant is that going to be in? Where is the tangent negative? Which one is the primary one? Is it 2 or 4? No, it's actually 4. It's 4. So I know this automatically is fourth quadrant. Okay? Now, I know that the sine of theta is 4 over root 17, but I got to figure out if it's plus or minus. Well, what is the sine in the fourth quadrant? What is the plus or minus sign of sin in the fourth quadrant? Yes. And I know this is fourth quadrant. That's the only place that the tangent is going to be negative, is fourth quadrant. Forget the second quadrant. That's not the primary. Whenever you see problems like this, it's the primary. In other words, you could actually do this a different way. It's not the correct way to do it, but you could look up the inverse tangent of -4, right? Your calculator, it's going to give you an angle. Then you look up the sine of that angle. And you're going to get minus some decimal number that's going to equal to -4 over root 17. This is the exact way to do it. It's not the only way. But if they want their answer in radicals, this is the only way. So this one was one level harder than the previous one because I could not assume that theta was a first quadrant angle. Because the inverse tangent was negative, that automatically made it a fourth quadrant angle. And the sine of a fourth quadrant angle is always negative. So that was a critical part of this problem, was knowing that this was a fourth quadrant angle. Yeah, I'm going to close this out. Hopefully I can get rid of this problem that I have. Okay. Yeah, here, let me pull it up. Didn't get your email. Does it say file sent on your end? Did you send it to davidcowan1949 at gmail.com? $19.49. It's davidcowan1949 at email or at gmail.com. I have not gotten it. Usually that means that it still says file sending on your end. Is it something you can't verbalize? Try to verbalize it. Try to verbalize it. Okay? Okay, so it's a graph. You can't verbalize that. There's no way to do that. I don't know of a way to do that. Okay? Let's try to do that graph, because these are hard problems, and the only way I can possibly help you with them is if you can send me a picture of the graph, and then I can figure it out for you. So try to resend it, and try to send it. Are you using an Apple phone? No, that goes to my phone. I'm on my computer. Need to send it here. Send it to the following email address. It gets to me. You just got to make sure you send it to the right place. It's an1949 at gmail.com. Just send it to there. It'll get to me. Send it as a large file attachment, large image attachment, or even regular. Just don't send it as a small image attachment. Okay. Now, these problems come in two different flavors. They come where they give you the function and they ask you to graph it. And the other flavor is they give you the graph and they ask you for the function. So we certainly could do the other kind, where they give you the function and we can graph it. Definitely can do that. But if you want to do the, here we go, I got it finally. I know I can handle this. I can rotate it. Might take me a minute or two to do it. Yeah, it's going to. Hold on. Hold on. All right. Wow. What happened? Try that again. Okay, I got it now. Let me open this with paint and I'll be able to rotate it. I'll rotate it 90 degrees to the right and shrink it. Okay. Okay, assume that that is a cosine curve. Determine the following. Amplitude. First of all, there's a very, very simple formula for amplitude. Okay, let me give it to you. Both the amplitude and the vertical shift are actually very simple. The amplitude is equal to the high plus the low divided by 2. What's the high here? What's the low? So what's the amplitude? Take the high, add it to the low, and divide by 2. Okay. Now, the other thing that's very simple is the vertical shift is the high minus the low divided by 2. So what is that? Okay. Those two things are huge, and they're very, very simple. Just got to keep them straight. The amplitude is the high plus the low divided by 2. The vertical shift is the high minus the low divided by 2. Hold on, I made a mistake there. The amplitude here is 3. I got it backwards. My apologies. In other words, first of all, the amplitude is the distance from there to there divided by 2, correct? In other words, if I redraw the line of symmetry, it goes right through that. And the amplitude is the distance to the first peak from the line of symmetry. So we can see that the amplitude is 3. So the amplitude must be minus, and the vertical shift must be plus. Because I can see that that vertical shift is at 5 from a base of 2. That's a shift up of 3. And the amplitude is clearly 3. It's the difference between 8 and 5. So the way to remember this is the amplitude is the difference, vertical shift is the sum. It's always that way. Well, I want you to read the thing and tell me. Read the graph and tell me what the amplitude is. Remember the amplitude? Yeah, no. The amplitude is the difference between the peak and that line. That's what amplitude means. It's the amount that it goes above the line of symmetry, the horizontal line of symmetry. So what is that distance? From here to there. So A equals 3, which in this case is the high minus the low divided by 2, right? In other words, you can always figure out what it is by looking at the graph, knowing what the amplitude is, and then figuring out if it's the sum or the difference. Well, in this case, it's the difference. It's 8 minus 2 divided by 2. That gives you 3. Well, what is the vertical shift? Correct. Vertical shift is how much the line of symmetry, the horizontal line of symmetry, has been moved from 0. Well, it's now on 5, right? So we can see that it's 5. And the way you get 5 is you have the height plus the low divided by 2. That's 8 plus 2 divided by 2. That's how you get 5. So the amplitude and the vertical shift are really, really easy as long as you can keep them straight. Okay? So, amplitude is 3, just the distance from there to there, right? Now let's talk about period. Period is the distance along the x-axis of one full cycle of this curve. Cycles go from there to there, or from there to there, or from there to there. You see why each of those is a full cycle? Okay. So what is the length of one full cycle? not 1. Read these numbers down here. We're going left to right. It's pi. Okay? So the period equals pi. Just reading it off the graph. That's all we're doing. Okay? That's always the way you do these. You read the amplitude off the graph, you read the period off the graph. Now, oh shoot. Assuming this is a cosine curve, not a sine curve, whereas they tell you it's a cosine curve right there, right? Tell me what the horizontal shift is, and whether it's left or right, and what the value is. In other words, what would I have to do to this curve to make it look like a cosine curve? First of all, you need to know what a cosine curve looks like. This is what cosine curves look like. Okay? With me? Okay. What do I have to do to this curve to make it look exactly like the curve on the right? Do I have to move it right? Do I have to move it left? Or can I move it either way? And by what amount? Correct. By how much? By how much is how much on the horizontal axis? In other words, if I'm going to take this whole curve and shift it to the left or to the right, what would work in terms of replicating this curve that I've drawn? Remember, that curve that I've drawn goes like this. So what do I have to do to this curve to make it look like that curve? Yeah, either one. Either one. Well, if I were to take this curve and move it left, that is a positive. Let's talk about something else here. Let's talk about the sinusoid function. We really can't do this problem justice. And you're obviously studying the sinusoid function, okay? Even the last question here says, what is the equation of the sinusoid function? So let's start with the general equation. Believe it or not, there's actually a number of general equations depending on which school system you're in. Is this the one you guys use? The other alternative is the b can be inside the parentheses. That's the key difference. So it's like this then. And they're different. They're definitely different. In the first one, your phase shift is c. In the second one, it's c over b. So it matters what you're looking at in terms of your standard sinusoid equation. There's even another school system whose general equation is this, plus c. Believe it or not, there's actually 3 different general equations. And you just have to know which one you're looking at. So, if you're telling me that your general equation is the b inside, Do you have an example? Can you look up your general equation? They'll have it in the section on sinusoid functions. Forget the fact that it's cosine for a moment. You need to know the standard general equation for what is called the sinusoid function. Even though it can have a cosine instead of a sine there, it's still called a sinusoid function. And you need to know what your standard is. Do you have something you can look it up, or I don't want you just guessing because it matters. And I'm going to say most school systems have the B outside the parentheses, just because it makes more sense. Okay, that's fine. We'll work with that. Okay. First of all, we've already figured out the A, right? What was the A? A is the amplitude. Get the amplitude by the highest value minus the lowest value divided by 2. Okay? And I'm still going to say sinusoid. What's D, the vertical shift? How far up has the horizontal line of symmetry, this thing right there, is at 5 instead of 0. So that makes the vertical shift 5. Okay? Now, Bx minus C. What did you say the phase shift? The phase shift is the horizontal shift. You said it was pi over 2, right? And it doesn't really matter whether it's pi over 2 plus or minus. Either one results in the cosine curve. So I'm going to change the function from sine to cosine. So I got that much of it. And that tells me the amplitude is 3. Let's talk about the period. We said the period was trough to trough or peak to peak, right? So what's the period? What's the horizontal shift? In other words, how much do I have to move it left or right so that it matches the cosine curve? Pi over 2. Okay. And it could be either plus or minus. Either one. If I move it pi over 2 to the right or pi over 2 to the left, I get the cosine curve. What's the vertical shift? Up or down? That's D. And so, what is my equation? Hold on, you don't have enough information yet. We have everything but B. So, well, B, there's one more thing you have to memorize. Oh, God, I hate this thing. There truly is one more thing that's absolutely vital here. And that is the period, hold on. First of all, you need to know that the period is always equal to 2 pi over b. Okay, so what does that make b equal to? You have to memorize that. No way around it. Gotta memorize that. The period equals 2 pi over b, so what does b equal to? Do the algebra. Multiply both sides by b and divide both sides by the period. So what do you get? Solve that circled equation for b over the period, right? Well, we read the period from the graph. You know the period is from there to there, correct? So the period is pi. So what's b? No, it's 2 pi divided by pi. What is 2 pi divided by pi? Right here. Okay, so b is 2. Now we know what a is, we know what b is, we know what c is, and we know what d is. We're ready to write the final equation. So y equals, what was a? We know it's cosine. What was b? I'm going to put it outside just because I'm unsure at this point. And this is, well, no, hold on. We don't need to do that. We can figure it out. So it's x minus c. What is c? C is the phase shift or the horizontal shift. What was that? Okay. So it's x minus pi over 2. And what was the final thing? What was the vertical shift? Here's your equation right there. Now, let's check it. And the way to check it is to try some values. If every value I try works, then it's correct. Okay? So let's try theta equals 0. We can see that that better be 2, correct? In other words, when theta equals 0, it's right there. Keep trying to circle it, but my thing isn't working. There, right there. That's theta equals 0. So let's plug in theta equals 0 and see if we get 2. Well, that's 3 cosine of 2 times minus pi over 2, right? Plus 5. Well, what's cosine of 2 times minus pi over 2 equal to? First of all, what's that? Simplify it. Here's what you're looking at. 2 times minus pi over 2. You've got to be able to do this kind of algebra, Brandon. So what is that equal to? Cancel. Always be thinking cancel. Okay, good. So now we need, what's the cosine of negative pi? Same as the cosine of pi. What's the cosine of pi? Nope. You got to know your cosine curve. If you want to be good at trig, you got to know your sine curve and your cosine curve. Here's the cosine curve. Starts at 1, goes like that. That's pi right there. So what's the cosine of pi? What's this point right there? -1. Cosine goes between 1 and -1, always. Just like sine goes between 1 and -1. Never is greater than 1, it's never less than -1. Your sine and your cosine. They just bounce back and forth between 1 and -1. What's important for you to know is where they're at 1, where they're at 0, and where they're at -1. Well, we can see that it's -1 at pi. So the cosine of negative pi is -1. Okay? Now substitute that in for our equation and see if that is correct. Cosine of that whole thing is -1. So now multiply that -1 by 3 and add it to 5. What do you get? Yeah, which is our point. So we've checked one point and it's perfect. That's all I need. That means our equation is correct, as written, with the 2 on the outside. Now, I could change this equation so that it is, here, let me write in a different color because I've scribbled this up pretty good. I could change it to y equal 3 cosine. I have to use cosine because they've insisted upon it, but I could do this. In other words, I can cancel out the 2's myself. So that's a satisfactory answer also for the equation of the sinusoid function. This equation, had they given you the equation and asked you to graph it, this is the graph you would have come up with, using pretty much the exact sequence that we used, only in reverse. Okay? All right, now let's have a look at the second one. Good, this is the other way around. Fortunately, we only have 3 minutes, but we can do a lot in 3 minutes. So, let's start with the easiest thing, which is the +6. What does that do to my line of symmetry? My horizontal line of symmetry. Vertical up by 6. So instead of being way down here, it's up here. I apologize for my screen problems there. That's my vertical line of symmetry. Now, do you know what? Excuse me. That's my horizontal line of symmetry. In other words, my curve is going to be about that horizontal line. What's my amplitude? Which means my high point is 2.5 above and 2.5 below. Well, there's my high point. There is my low point. Remember, the amplitude is the distance between those 2 points, which is 5. Okay, you with me? Let's do the phase shift next. -4. What does that do to my starting point? Well, it moves it to the right by 4 units. Okay? Well, if I start on the far left and go 4 units to the right, that's my new axis right there. Okay? So now I have 2 parts of that grid. I've got that part and this part. So all I got to do is draw a cosine curve that fits that. Well, I know where the cosine curve begins. It begins right there, right? Now, the only thing I have to know is the period. And they've made this as tough as possible. In other words, the b being, notice that the b is actually outside the parentheses. It's inside the brackets, but it's outside the parentheses, which is the normal way. That is the most normal way, okay? You understand the difference? It's inside the bracket, but the important part is it's outside the parentheses, x minus 4. So that means that b is equal to pi over 3. So what's the period? Remember, the period is 2 pi over b. So what's my period? I'm going to do this real quick because I know we're out of time, but I can finish this. So my period is what? Well, it's 2 pi divided by pi over 3. That's 6 pi. Okay, in other words, it's 2 pi divided by pi over 3, which is b. Reverse those, actually it's 6. The period is 6. Okay, so that means I'm going to start everything there, and a full cycle takes me to there. Now I have everything I need to draw this thing. I have to draw it starting there. I have to go there and end there. There's one full period. And that's pretty much it. I've drawn it. It is pretty easy. Once you get these sinusoid functions down, you have to remember that. The period is 2 pi over b, always. Because you'll know either the period or you'll know b. And knowing one will tell you the other. Okay? All right. I will let you go. And this is good stuff. It's tough stuff, but I think you actually have a pretty good handle on trig. I do. You just have to memorize this stuff for the sinusoid function. And also know that the sinusoid function is just like transformations. Everything is. A is the vertical stretch factor. B is the horizontal stretch factor. C, the phase shift, that's the horizontal shift. And D, that's the vertical shift. Same exact thing. Why they give it 4 different names, I'm not sure. But they do. They do for a reason. I'm still not sure what the reason is, but understand that that's all they're doing, is they're taking a algebraic equation and transforming it. All of these things are the same thing, only it's a sinusoid function. And you have to be able to go both ways. You have to be able to take the function and graph it. You have to be able to take the graph and come up with the function. Once you can do that, you are set for life. If you can do those 2 things. Okay? All right, Brandon, I will let you go. Have a good one.